this is a CART tree. And one of my reasons for running CART in this software is if I want a variable ranking, I can only get it out of the CART tree. But here's where the population comes out as one of the predictor variables. Okay, so this is the ranking in predicting whether there's a subprime problem in the zip code. So the number one variable is the percent of loans approved in the zip code. And number two variable was the median loan to income ratio. So I'm just, going to mention those two as top variables. Okay, then next I ran a tree on the foreclosure score. And again, that was, I used basically split the data into the worst 10% and everything else. And the first variable out on this tree is whether or not the loan was denied, the percentage of loans that were denied. And you have to keep in mind that there were a couple of variables in this data. One is whether some codes related to whether or not it was approved, and there were some codes related to whether or not it was denied. The two have slightly different data in it. So they're highly related but slightly different. So, and it just so happens that for this tree, the denial percentage rather than the approval percentage came out as the first variable. But other predictive variables were the zip code population and the average loan amount. So the ranking of variables on the foreclosure score, the most important variable was the percent denied. There also was a score that was in the data that had to do with the loan being denied. So the top two variables have to do with the loan being denied. The third one has to do with the variable about approval. And finally, you get below just approval denial variables. Keep in mind, by the way, when I was aggregating this data up to the zip code level, for a number of these variables, I took a number of statistics, so a mean and a median, and sometimes certain percentiles and things like that, which is why you get the same variable appearing a few times, because there were different statistics that were collected on it. But you do get the population for the zip code and the percent of the properties that were not 1 to 4 families. Also, you get the rate spread as an important predictive variable. Okay, now, the other thing I wanted to show was that if you had some data relevant to the quality of the loans, you could do some unsupervised learning. So in general, when you're dealing with loan information, you may be able to use an unsupervised method to indicate what kinds of loans might be the more problematic ones. So this is just a graph produced from running random forest in clustering mode rather than in predictive mode. So, and I don't have time here to explain that, but there is, a second capability that random forest has that can be used for unsupervised learning. So this is just showing that it sort of gets two key factors out of the data, and the score on that factor. This is using the score on that factor to help predict whether there's a delinquency problem in the zip code. And this is just a receiver operating characteristic curve, just showing that you get some lift from that variable just from using some unsupervised learning. And this unsupervised learning, I did not include in it whether or not the loan was approved. I only included, income, loan amount, loan to income, just all the variables that had to do with the riskiness of the loan, but not the outcome. Okay, and this was just applying k-means clustering. So what I want to show you here is that when you apply k-means clustering, again, just to the riskiness data, not to the outcome data, this is where I used the clustering to create 4 categories. And what you see here is that there is a little bit of variability in the percent approved according to those categories, but there's a huge amount of variability in this average score on subprime problem, also on the average score on whether there's a foreclosure problem, and then the delinquency component. So again, by doing some unsupervised learning on characteristics of the loan, we seem to be able to cluster the data into groups that have problems and groups that don't have a problem. Okay, I need to mention some limitations of the data. The HMDA data is from the 2007 calendar year. And the foreclosure and subprime problem data, problem scores, are from the 2000 calendar year. So they're both from the same calendar year, but there is a mismatch problem in loan versus the 2007 year HMDA data. That's the year those loans were originated. And the problem has to do with the year a loan defaults is usually not the year it's originated. And that's what this overhead is showing. You can see that if you take a particular origination year and you follow it over time, the default rates tend to increase over time. So default rates for a cohort of loans evolve over time. We were only in the default score data that I collected I was only able to get it at a calendar year point in time, which means that if I took the 2007 calendar year, it was a mixture of a bunch of different origination years. So my belief is that, this is just showing it graphically, that default rates evolve over time. Okay, so the consequence of that is that the default rates in 2007 are primarily attributable to loans originated in years before 2007. Probably 2005 and 2006 were, they were probably 2005 to give it some time for the rate to reset. But 2006 and 2007 year foreclosures started going south earlier than was typical. But the result, I believe, is that that it's likely, the 2007 default rates are largely driven by conditions in earlier years, and this affects the interpretation of the tree results. And what I'm trying to say from all of that is that the approval and denial rates were kind of predictive of whether or not there was a foreclosure problem in that zip code. I'm suggesting that in 2007, they started to get with the program when it came to underwriting, and they started to deny the loans the types of loans they should have been denying all along. That's a hypothesis that the data suggests could be true. Population and interest rate spreads are additional important predictors of subprime problems, and loan to income is an important predictor of foreclosures. Oh, one other thing I wanted to show. A whole lot of the credit agency pricing was done with data that began in 2004. 2004 is right around here. They assumed that housing prices on a countrywide basis never go down. So here's where their data started, and of course it didn't go down in that period. But if you start the data series and include many more relevant years. And this is from Case-Shiller, by the way. They put out a housing price index. You could see how utterly ridiculous that assumption is. But sure, if you use only 5 to 10 years of data, you can get it to say anything you want. You just take from the optimistic period, you'll get an optimistic answer. And I just wanted to show you a website where the objective here is to start putting together a good database for doing some systemic risk regulation. You might want to visit the website and sign their petition. Because one of the things we will need to prevent this in the future is good data. I mean, we need to use what we have, but the systemic regulators are going to need to collect some data specifically for what they are doing. Some references. I actually wrote an essay on the financial crisis. There was a call for essays sponsored by the Joint Risk Management Section, which is an actuarial enterprise risk management organization. The Markopoulos testimony can be found on the web, by the way. And a draft paper on everything I've presented here should be ready within a month or so.